Hello everyone, and welcome back to another R geospatial statistics tutorial video. And in this video, I want to talk about the last of the nearest neighbor analyses. And this is going to be the second order L statistic, which again is basically just a augmented version of Ripley's K to make the outputs linear, but it's still worth going through because it is a separate function in SpatStat. So again, make sure that you have GIS tools and SpatStat packages installed. Because we've already gone over it with the GStat, I'm not going to go through the whole mapping process again. We're going to talk directly just about what you would need to do at a minimum to use what is now going to be the LEST, L-E-S-T, function in SpatStat. So let's just take a quick look at the function that we're going to use. Again, it's from the SpatStat package, and it's going to be LEST, L-E-S-T. And you're going to see that it looks very similar to the GEST and the KEST, but in this case, we're using the L function, which again is just a transformation of Ripley's K. So same sort of process, right? Big X, which is going to be, again, that PPP transformed data set, and the same correction method applied from the Ripley's K. So we're going to use that isotropic correction. So let's go ahead and just quickly run through how this is going to look in code. The first thing we're going to do, as always, is load a data set. So I'm going to load the New Haven data set. I'm going to make sure that I have my breach variable set up. And again, I'm just doing this to make sure that you know what I'm doing. This breach equals breach is not strictly necessary. What is necessary though, again, SpatStat has its own spatial data set, which is again kind of obnoxious, but that's the way the package is. So you need to make sure that before you use SpatStat, that you convert from your spatial polygon data frame or your simple features, or sorry, spatial points, spatial points, not polygons. This will not work with polygons. From your spatial points or spatial points data frame or simple features to PPP. And again, that is done with the as.ppp function, and you pass in your data set breach. Okay, so now we have a PPP version again. And we are going to then run our LStat. And again, this is going to come from the SpatStat package. Actually, I guess to be clear, this also came from SpatStat. Technically, not strictly necessary to do this, but I find it's really good practice to always be explicit what package you're using. So from SpatStat, we're going to call it capital L-E-S-T. This is the L estimate. And again, it takes in two parameters that we need to worry about. First is capital X, which is our PPP converted data set. And the second is this correction parameter, which is going to be isotropic. Okay, so if we run that, we don't get any errors, which is perfect. Let's take a quick look at what LStat looks like. Again, right, this is the exact same thing as our Ripley's K, where we have the distance, we have the theoretical that was calculated based on Poisson distribution, and then we have our isotropically corrected calculated L. So what we can do, just like before, we type in plot, and then we type in our name of the variable that we called. In this case, I called it LStat, and we run that. And we run that. What you'll see here is, again, just like with the GStat, just like with the KStat, right, we have this dashed line here that represents the expected Poisson value. And this is a one-to-one line because what the LStat does is it makes the Ripley's K linear. And anywhere that the calculated value is above this line, it means that your data is clustered. Anywhere that is below this line means that it is dispersed. So again, you're going to take those same conceptual interpretation and apply it to this plot. Hopefully that makes sense. If you have any questions, please reach out. Thank you.